So now we will discuss about your population dynamics. After understanding what is biotic potential, what is environmental resistance, what is population, okay, what is actual abundance. Now we will try to understand your population dynamics. Okay, so what is population dynamics? It refers to the study of the changing density of an insect pest both in time and space parameter. And why that is occurring, understanding the process which is causing their change. Understood? Dynamics of the population, that means change in density of a particular pest or any organism in with respect to both time and space, time and area, and understanding why that has been changed. Understood? That is known as what your population dynamics. Understood this one or not?
Yes, sir.
Understood?
Sir, please
Okay.
explain much more in detail.
Much more in detail. Tell.
Repeat
Hello?
once again, sir.
Okay.
Yes, sir.
Okay. Listen. Suppose during winter season or suppose during rainy season, aphid population is reducing. That means the time is specific and the area is specific. Suppose in the School of Agriculture, the aphid population is decreasing during rainy season. This is what your normal the population or the population density. Understood that one? In rainy season, in School of Agriculture, the aphid population is decreasing. That means in summer season you might have studied per leaf this much of aphids are there, but in rainy season you have seen no per leaf, only few aphids are there. Understood? The density, that means the population of the aphid in a unit area, in a particular leaf size, I think this much centimeter square, the aphid population has changed, either increased or decreased. Understood?
Yes.
Yes, sir.
Understood that one? Yes or no? This is
Yes.
first part. What is second part? Understanding the process which caused the damage, the change. That means why change not damage? Because it may increase also. Yes or no? That means what is that? No, if rainfall will be there, as the aphids are very minute insect, they may wash away. Or if moisture will be there, they cannot tolerate that moisture and they will die. Getting my point or not? So this is the reason behind the change. You have understood the change in density of the population. Also, you have understood the reason behind that. That is known as what your.
Why cannot say that it is damage? Why we can say it is change?
I told you now, damage means that will reduce or induce the population. Damage
It may
means.
increase. Okay, sir.
Hello?
Okay, sir.
It will reduce, yes or no? But change means it's not only reducing, it may increase also. In case of cotton, they will come more in case of rainy season. That is also a change. Yes or no? That is not damaging the pest, it is increasing the pest. Getting my point? That's why you should not tell damage, you should tell change. Okay? Clear?
Yes, sir.
Yes, sir.
Okay. Now coming to some terminologies are there. Okay, some terminologies are there. What are those? First is density. What is density?
Distribution of population by unit area.
Population by unit area, yes or no, volume or whatever area you are taking. Then birth rate. What is birth rate?
Number of individual born per unit area.
Individuals are added. Suppose 50 are there. In the next month, some will be added. That is the birth rate. Yes or no? What is the death rate?
The rate at which
Individuals are decreasing.
initial
Yes.
population.
Lost from the initial population, yes or no? That is what your mortality and birth rate is your mortality. Okay. Then what is dispersal? Dispersal.
Immigration or emigration.
That means some are coming inside, some are going outside. Yes or no? Immigration and emigration. Yes or no? What is dispersion?
Distribution of any insects in a space.
In a space, yes or no? In the first experiment, we already have discussed dispersion. Okay. Then what is age distribution?
Distribution of different ages of insects in
Just human survey, yes or no? Just like some are child, some are infant, some are mature, some are older, yes or no? Similarly, in case of insects, some are larvae, some are eggs, some are pupa, some are adult, yes or no? Age distribution. Then genetic characteristics.
the fecundative rate, what is that adaptance, what is the distributions, how they
Yes.
increase.
all those adaptiveness, yes or no? How their genetic is acquainted or affected by the environment, yes or no? That is what your genetic characteristics. Fitness, mortality, everything will come inside that this genetic characteristics, yes or no? Then population growth form. Okay, this one we will understand now. The way in which population changes, that means either grows or reduce, okay, is a result of natality, birth rate, mortality, death rate, and dispersal, emigration or immigration. Now we will understand the population growth form. Okay, so two type of growth form are there. Okay, one is J-shaped growth form. Okay, another one is your S-shaped growth form. Okay, one by one we will discuss. First, coming to J-shaped growth form. Okay, in such cases, what will happen? Just like your R strategy. What is R strategy?
High reproduction rate and low survival.
Low survival rate.
Survival. That means, okay, that means now you tell me, in case of aphid, when the environment, the whole biotic and abiotic environment, that is totally favorable for them, how they will increase? With a boost, yes or no? If everything is favorable, then what will happen?
Rapid manner, then
very quickly, very enormously, they will grow, yes or no? That's what is what they have formulated. In such kind of J-shaped growth form, or in case of aphid or R strategy insect, the population density increases in an exponential or geometric fashion. That means first 2, then 4, then 8, then 16, then 32, then 64. Like this, what will happen? Very quickly they will grow. Yes or no? Getting my point?
Yes, sir.
Yes, sir.
They will grow like this, but if a sudden change will come, if a sudden or any form of sort also, some kind of deficit will come. It may be either presence of higher amount of natural enemies or shortage of the foods or any kind of unfavorable abiotic condition. Okay, at that time what will happen? They cannot survive anymore because they have R strategy. That means they have very less survival rate. Am I audible?
Yes.
Yes, sir.
Yes, sir.
Okay. At this time, what will happen? Very quickly, okay, abruptly, what will happen? Their population will decline rapidly, coming to an end. Understood?
Sir, the example of J-shape is similar to the R strategy with the aphid, sir.
Same. Our strategy comes under J-shaped growth form. Okay? All are same.
Okay, sir.
Only it is in terms of graphs, that is in terms of definition. Understood?
sir, this line why it zigzag, sir? It should be one line.
Could not understand?
The declining line that is shown in this figure, it is in a zigzag manner. So it should be a proper line, sir.
Why zigzag? Where zigzag is there? That is this space you are telling or what? No, it is
No,
not
sir,
zigzag.
that line is not in a straight line, sir. That is the issue.
Not zigzag. Actually, only to differentiate between this is the increasing line, this is the decreasing line. That's why it is kept like this. Okay, not zigzag. Very quickly they will reduce down.
No, sir, I am asking about why there is spaces between that line.
No, it is only to differentiate between this is increasing line, this is decreasing line. That's why. Understood? There is no concept behind that. Only increasing line, okay, and that is decreasing line. That's why. Okay. Like you see, this is this side is number of individual over time. Over time, first they will increase in the geometric fashion. Okay, 2 to 4, 4 to 8, 8 to 16, 32, 64, like that. Then, if any kind of unfavorable situation will come, directly they will stop down. Okay, there is no concept behind this space and all. Okay, understood?
Yes.
Yes, sir.
So, is it a stable form or is it a unstable form?
Unstable form.
Unstable form.
Yes or no? Okay. Now coming to the S-shaped growth curve. Okay, S-shaped. Okay. Here what will happen? You see, in this type of growth curve, here what will happen? At first, what will happen? They will increase in a increasing rate. At first, if favorable condition will come, they will increase in a increasing rate. Okay, up to some point. That means the condition is totally favorable, but not like affects. Suppose any moth is there on any kind of bees are there, any kind of case strategy insect. Then what will happen? If also favorable situation is there, they won't reproduce just like aphids. They will reproduce on their own term, on their own pace. First, what will happen? They will increase their population in an increasing rate. That means, just like, first is 1, suppose then 3, then 6, okay, then 9, like that they will go on increasing. Okay? That means 1 to 3, the difference is 2, yes or no? 3 to 6, the difference is 3, okay. Then 6 to 10, that is 4, like this. The gap is also increasing, yes or no? First is 1. Are you getting my point? I think no.
Yes.
Yes, sir.
Understood, increasing and increasing rate, both are different, yes or no? You see one insect is there, that is first is 1 number, then 3, okay, then 6, okay, then 10, then 15, like this. Here what is happening? The difference in between also increasing. First is the difference is 2, then it became 3, then it became 4, then it became 5, then it will become 6, like this. It is increasing with increasing rate. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
After that, what will happen? They will increase in a decreasing rate. What do you mean by that? Suppose after 15.
15, 10, like 6.
No. The population won't decrease. That will become 19 instead of 20. The difference is becoming now 4. After 19, what will happen? It will become 22. Getting my point? The difference will be 3. I think you are not getting. Just
Yes.
so two things are there. So one is what? Increasing in a increasing rate, then increasing in a decreasing rate. Okay. First, coming to this first point, increasing rate means what? First is 1, then it will become 3, then it will become 6, then it will become 10, then it will become 15.
15.
What is happening here? You see, difference is 2, then 3, then 4, then 5. Yes or no?
Yes, sir.
Yes, sir.
But in this increasing in a decreasing manner, what will happen? Suppose 15 is there. Okay, after that, what it should become here? Plus
19.
6. Actually, what should be there? Plus 6 means 21. Yes or no? But here, what will happen? That will be 19. Getting my point?
Yes, sir.
Difference is 4. Then what will happen? It will become, suppose again decreasing. Suppose then 22. 19 plus 9, 3, 22. Yes or no? Getting my point? Difference is 3. Similarly, after that, what will happen?
24.
Plus 24. Getting my point? No doubt the population is increasing only, but here that is in an increasing rate, here that is in a decreasing rate. Understood the things?
Yes, sir.
Yes, sir.
Yes, sir.
Clear? Okay. So here what will happen? First they will increase in a increasing rate, okay, up to some point like this. Then they will increase in a decreasing rate. But when the temperature or any kind of environmental factor is totally unfavorable for them, okay, they will reach a level, this level, beyond which they cannot increase that much, okay, and they will try to fluctuate their population density around this line. This line is known as what? Your asymptote in case of statistics, but in case of your ecology, it is known as what? Your carrying capacity. Understood? Yes or no? First, they will increase in an increased rate. Then they will increase in a decreasing rate. Then they will be achieving a place or a point beyond which they cannot reproduce. Just like aphids, they cannot reproduce. What they will do? Even though unfavorable situation is there, they will try to fluctuate around a particular position. The position is known as what? Your asymptote in case of your statistics. In case of your ecology, that is known as carrying capacity. Understood?
Yes, sir.
Yes,
Yes,
sir.
sir.
So how to define a carrying capacity? Carrying capacity of a population is defined as the maximum number of individuals that can be supported in a given habitat. That means at this point, suppose this point is some 300, suppose 300, okay, 300. That means if some favorable condition will come, it may become 350. If any unfavorable situation will come, that may become suppose 250. But the average will be always 300 or nearby 300. That 300 will be known as what your carrying capacity. Maximum number of individuals that can support in a given habitat in a given time. That is known as what your carrying capacity. Clear?
Yes, sir.
Yes, sir.
Yes or no? Huh? Okay. This is what your asymptote or carrying capacity. Okay. And once the population will reach the carrying capacity level, its size will fluctuate around it. You see, the size is fluctuating. Yes or no? The reproductive rate is less because this is K strategy, and survival rate is more because this is again K strategy. And it is more stable and most found in case of your lepidopteran insect, hymenopteran insect, coleopteran insect. For them, such kind of S-shaped growth curve will be there. Understood? It is also known as sigmoid curve. Okay? Clear?
Yes, sir.
Yes, sir.
Yes, sir.